Welcome to Harbin Double O, or indeed, welcome back to Harbin Double O. Been a little while since I put a video up there. I think the last one was, the last actual video was the 360 turntable for Merg. As a result of the Merg one there, I put a cheeky bid in on eBay for 5 servos there. Also bought a one for Merg from Amazon for £10 and I won the 5 servos for just over £10 on eBay, so they're now surplus. So I decided to upgrade my camera mount. This is the old one, which is a bit of pipe, copper pipe, 15mm. And I use one of these magic arms as well to put the camera in. And over the last few years I've had nothing but hassle and no joy at all trying to adjust this to get the camera at the perfect angle. So I decided to upgrade the camera mount on the workbench. So I'll take you across and show you the camera mount as it is now. It is in a working state at the moment. I've still got a lot of cable management to do, boxes to do for controls, etc. But I'll take you across and let you see where we are now with the camera mount. This is the new camera mount there, folks. It's a bit of aluminium extrusion, 30-30 and 20-20 aluminium extrusion. It's run on top of linear rails and it's also used lead screws as well. I have got this pan and tilt on it. I'm not exactly happy with it, folks. I think the camera just sitting here using this bracket here. The camera sits quite nicely, just like that. It's all controlled off one of these HW702 boards. Got this one from AliExpress in China, £1.54, and it's got a couple of drivers in it now. These are quite noisy, these drivers, folks. I can upgrade to the silent drivers, and they're £10 each, so that's hammed and hawed with it. The wee Arduino, I got 5 from AliExpress as well for the Nano, for 5 for just over £3, it's not too bad. Let's run off this little joystick here. So if I move it in or out, or in and out, you see it moving in and out there. And that's also got the horizontal as well, up and down controls. If I press the button, that puts on the mode for this one here. Now the servos are 5 volts and you've got to have the 5 volts with a common ground. That's the reason for this wire here, folks. So if I turn it around, up and down there, you can see it, folks. And it goes, it'll jiggle as well when it's moving there, folks. I've not got the third screw in here. That's it again, it's got the pan and tilt on it. So I'm not enamoured with the pan and tilt there, so I probably will just have this bolted on there with the camera facing down the way. So I'll take you out of the computer, folks, and I'll show you how I designed all these little plastic bits. And just in case you're wondering there, how come some are white and some are blue? A good reason for that, folks. I ran out of white, so blue it was. So I'll take you out of the computer there, folks, and I'll show you in Fusion 360 how I set this up. I started off in Fusion with the NEMA 17 stepper motor. I got this one off a GrabCAD and just imported it into the Fusion 360. So with that, the most important part was this face here, so I could start building the stepper motor mount. I did get 2 or 3 parts of the stepper motor mount and the carriage off of a website called Printables. It was an actuator I downloaded and it was built for a NEMA as well, so it was quite compatible. So from that we've done the stepper motor mount and added 2 or 3 more bits into it for end stops and things like that, which I end up not using at the moment. I then went into up here with insert and this McMaster car component. This has got thousands upon thousands of hardware, including lead screws, linear bearings, and so on with it. And it's all step files as well, so you can import it in your drawing. You can order it. I'm not sure about in the UK, but certainly in America you can order of it as well. And it's meant to be good quality, but you get what you pay for, as I say. So from there I put in the lead screw. And there, so you can see it's a big long one. And on the lead screw I put in the carriage. And you can see this has got the little slots and that for the screws and nuts and bolts with it. I then put in the carriage plate. There are 2 plates there, one for the carriage and also one for the camera as well. Technically speaking, I didn't need this one here, but I like to have the 2 so I can slot them in and out. I then put in my lead screw and also the lead screw, the linear bearing, and the little bearing itself, this part here. So moving up to the top of it, I put in the power square bearing, and I also put in the light mount and the 2020 aluminium itself, and from that I could design and build my little mount for the bearing at the top end. And you'll notice I put a couple of holes in here so I can put in some T-slots as well to hold it in place. So that's the actuator for the in and out part. This is the one for the 3030, the up and down one. I used the 3030 aluminium, and you can see the plate here. I've done a more beefier one for the mounting it onto the workbench itself. And you can just see the bits and pieces there in the bearing top yet. Also missing the lead screw. I was putting it out, you can see it. That's the lead screw in here. And this is all done with joints and things like that, moving, copying with it. So that was the design of Fusion 360. I'll now take you over to the Arduino IDE and I'll show you a bit of the program. I'm not going to go into too much detail with the programming, folks. I'll just give you a rough idea how it works. I included 2 libraries, the Excel Stepper and the Servo H library as well there. The next thing is the pins. This is where the pins go to on the HW702. Different pins go each way, your pan and tilt, and the joystick go into the pins as well there. And the steppers, they were set up, the servers were set up, the server position was set up for starting. It actually goes to 90 on setup. And then in your settings, you've got a dead zone for the joystick. In other words, if you're at 1 or 2, 3, 4, the stepper motor would try to move, so you put a wee dead zone in there, so if it's not quite centered, it wouldn't move. And then you get your speeds for your stepper motors, and the acceleration as well for your stepper motors. And a little bit of delay put in for the stepper motors as well there. I also put in a timeout for the stepper motor, so I wasn't using power all the time. After 3 seconds of movement, they shut themselves off. Then on your variables there, put in debounds, etc. So we wouldn't get any false readings off it. And also a bit of debugging as well. And then the main setup, just set up the debugging, set up the steppers, set up the servers as well. Now your main loop is just going through, reading the joystick, come back, moving it, if the button's been pressed or not been pressed, etc, etc. And the main loop does go right through quite a bit, yeah. So the servo control, the stepper motor control, using the accelerator as well, and then disable the stepper motors if they're not required. So that's the program there, folks. I've since done a wee box here, so I'll take you back across the workbench and I'll show you the little box the components are in now. Well, that's it, and it's a little box there, folks. I've got a little sheet as well here, just a pin out sheet for the pins for the Arduino as well. So there'll be a helpful reminder here, try to wire it up. I have done away with a pan and tilt at the moment. I wasn't too happy with it, so this is the final one there. So to go down, obviously a bit of noise there, folks, as you can hear. And we've got in, and we've got out, and we've got up, and we can do both at the same time, of course. So that's us there, folks. The prototype's done. As I say, more than happy with the mount. It's not too close to the eyeball with the lead screw, and it's got a wee cap on just in case it is too close. So, thanks for watching, folks. We'll catch you again some more time. Cheers.